students! Today is April 27th. It's the first lesson of the 6th week. In this lesson, we're going to talk about elements, compounds, and mixtures. Prepare your science notebook and your stationery, and let's start. On the top of a new page of your science notebook, write the date and the title of this lesson. Our objectives for this lesson are: describe the differences between elements, compounds, and mixtures, classify pure substances into elements and compounds, classify mixtures as homogeneous or heterogeneous. Who am I? I have a nucleus. I have no overall charge. My nucleus has a positive charge. I'm made up of protons, neutrons, and electrons. If your answer is atom, you're correct. Do you know? You need a stack of about 50,000 aluminum atoms to equal the thickness of a sheet of aluminum foil from your kitchen. Which one is smaller, an atom or a human cell? A typical human cell contains roughly 1 trillion atoms. So, an atom is way smaller than a human cell. A speck of dust might contain 3 trillion atoms. How many atoms do you expect in 1 grain of salt? It would take you around 500 years to count the number of atoms in a grain of salt. So, pause the video, then come back when you'll finish counting. Or do you know, let's postpone it. So, everything is formed from atoms. Do you know that each atom is formed from subatomic particles? Pause the video and assign each subatomic particle to its name, charge, and position in the atom. The center of the atom is called nucleus. Inside the nucleus, we have protons, which are charged positively. The other subatomic particle inside the nucleus is the neutron. The word neutron came from neutral, which means no charge. Outside the nucleus, we'll find the electrons, which are charged negatively. In front of me, many kinds of atoms. What's the difference between one kind of atom and another? The answer is in the number of subatomic particles. The number of protons, electrons, and neutrons varies between one kind of atom and another. Let's take a look. Starting by the number of protons, hydrogen contains 1 proton, carbon contains 6 protons, and iron contains 26 protons. Accordingly, if the nucleus of an atom contains 1 proton only, the kind of this atom is hydrogen. If the nucleus of an atom contains 6 protons, this means the kind of this atom is carbon. And so on. I'll never have a carbon atom which contains 8 protons. If there are 8 protons inside the nucleus, the kind of this atom will be oxygen. Referring to this table, what's the kind of the atom which contains 17 protons? If your answer is chlorine, you're correct. Right now, compare the number of protons to the number of electrons for each kind of atoms. It's clear that the number of protons is equal to the number of electrons. As an example, carbon contains 6 protons and 6 electrons. Oxygen contains 8 protons and 8 electrons. Is the number of neutrons is always equal to the number of protons? If we'll take chlorine as an example, The nucleus of chlorine contains 17 protons and 18 neutrons. Similarly, in the nucleus of iron, there are 26 protons and 30 neutrons. So, the number of protons isn't always equal to the number of neutrons. We arranged that the number of protons is equal to the number of electrons, and a proton is charged positively and the electron is charged negatively. Take a minute to find why an atom is neutral while it contains positive and negative charges. In an atom, the number of protons inside the nucleus is equal to the number of electrons outside the nucleus. Thus, the number of positive charges is equal to the number of negative charges. When each positive charge is cancelled by a negative charge, an atom is neutral. What do we have when one type of atom will bind? They form elements. Elements are made up of one type of atom, on its own or bounded to another atom of the same type. In this picture, all of these atoms are iron, and there's nothing else. When I'm talking of one kind of atom only, this means I have element. How many kinds of atoms do I have in this picture? Just one kind of element, which is hydrogen. Does this atom stand by its own? No. Each two hydrogen atoms join together by a chemical bond. Accordingly, hydrogen is an element formed from two atoms joined together. Similarly, in the second picture, we just have one type of atom, which is oxygen. So I'm talking about an element. This element is formed from two atoms joined together. Right now, let's talk about H2O, which is water. Do I have only one type of atom? No, there are two types. The first type is hydrogen and the second is oxygen. So is water an element? No, it isn't an element because I have more than one type of atom. Water is a compound. What do we mean by a compound? A compound is made up of different types of atoms bounded chemically. If I'll take one particle of water, I'll have one oxygen atom joined with two hydrogen atoms. Let's put it all together. Elements are made up of one type of atoms that exist either as single atoms or bounded to each other. Compounds are made up of different types of atoms that are bounded chemically. Right now, let's check your understanding. Copy the diagrams in your science copybook and identify each as an element or a compound. Justify your answers. Pause the video, then start it again when you're ready. Are these atoms identical in the first picture? No, they are formed from different types of atoms bounded. Accordingly, it's a compound. Are atoms alike in the second picture? Yes, they are. If I pick up one particle, it's formed from two identical atoms joined together, and then it's an element. How are atoms in the third picture? In the third picture, atoms are alike, so they represent element because there is only one type of single atoms. How many types of atom do I have in the last picture? Two types of atoms which are chemically joined, so it's a compound. Elements and compounds are called pure substances. Pure substances have exactly the same composition. The composition of a pure substance is always the same, regardless of its source. So, when I ask for distilled water, it's always H2O particles and nothing else, regardless which supplier I'm dealing with. The composition of helium is the same. In all sources, I'll just have millions of helium atoms and nothing else. Similarly, oxygen is a pure substance. I'll just have oxygen particles and nothing else. Do you think the composition of salad is the same everywhere? I personally don't like fried bread in the salad, so I remove it before adding the sauce. Accordingly, the composition isn't the same. When I'm able to remove the bread, this means there's no chemical bond between ingredients, and the bread stood as it is before and after adding it to the salad. It'll maintain its color, shape, and taste. Here I have another example of mixture. It's mainly formed from nuts. Your mixture might have more almonds, so the composition isn't the same. I'm able to separate one almond alone, so there are no chemical bond between ingredients. Each almond keeps its taste and texture before and after adding it to the mixture, so each substance keeps its own properties. Right now, pause the video, fill in the blank, then start again when you're ready. A mixture contains two or more substances that are not chemically joined together. The substances keep their own properties. You can easily separate them by using physical methods. These methods will be discussed in Lesson 2. Let's summarize. Matter is classified into pure substances or mixtures. When I say pure substances, this means there are elements or compounds and nothing else. An element is made up of one type of atoms that are either single atoms or chemically bounded atoms. A compound contains two or more elements that are chemically joined together. A mixture is made up of two or more substances that are not chemically combined, so I'll separate each substance alone. Identify whether each picture represents a compound or a mixture. Justify your answer. In the second picture, the composition doesn't vary. It's the repetition of the same pattern and nothing else is added to this pattern. So I'll have pure substance. It's clear that the atoms aren't alike, so I have a compound. In the first picture, the composition varies, so it's a mixture. Copy each diagram in your science copybook. Identify whether each one is an element, compound, or a mixture. Justify your answer. Pause the video, write your answers, then start it again when you're ready. How are atoms in the first picture? All are alike, so I have one type of atoms and then neon is an element. In the second picture, I have three different particles. The first is CO2, the second is O2, and the third is N2. Accordingly, I have three particles which are mixed together. Are these particles chemically combined? No, there's no chemical bonds joining O2 to CO2 to N2. And then the second picture represents a mixture. How are atoms in the third picture? All of them are alike. Great. If I pick up one particle, I'll have two atoms of nitrogen chemically joined. So I have an element formed from two atoms of the same type. Are particles in picture D alike? No, they are not. I have two different kinds of atoms chemically combined. The first is hydrogen and the second is oxygen. So H2O is a compound. We arranged that a mixture is a combination of two or more substances. Lemonade is a combination of lemon juice, water, and sugar. It consists of three substances mixed together without chemical bonds. Other examples of mixture: salt water, salad dressing, and air. Both the lemonade and the salad are mixtures. But what's the difference? They are different in how the materials are mixed up. The lemonade has a uniform appearance. The particles that make it are too small to be seen, and the mixture has a uniform appearance, so this kind of mixture is called homogeneous mixture. Other examples of homogeneous mixtures are tea, ink and water, salt and water. Are you able to differentiate between the particles of tea from the particles of water? No. The appearance of this mixture looks the same, and then I have a homogeneous mixture. Similarly, I'm not able to differentiate between the particles of ink from the particles of water. The appearance is uniform, and the ink and water form a homogeneous mixture. And it's the same for salt water. Do you have other examples of homogeneous mixtures? Both salad and nut mixtures consist of visible different substances. The substances remain separate. The substances in the mixture can be separated easily. I might pick up a piece of radish or an almond by my hand. What do we call this type of mixture? Heterogeneous mixture. Other examples of heterogeneous mixtures: the soil, cereal and milk, water and oil. Look how the substances forming soil are easily shown. I can take a rock by my hand. In the cereal and milk, the mixture isn't uniform as well. I might take a spoon of milk only, or picking up a piece of cereal alone. Look at the mixture of water and oil. It's clear that it's formed from two parts. The first part at the bottom is for water, which has more density, and on the top we have oil. Copy the following graphic organizer in your copybook and fill it using the following terms. Take your time, and when you'll be ready, start the video again. So, matter is everything that has mass and occupies space. It might be pure substance or a mixture. This pure substance might be formed from one type of atoms only, and then it's an element, or formed from many kinds of atoms chemically combined, and then it's compound. A mixture is formed from more than one substance physically combined. If the appearance is the same all over the mixture, it's a homogeneous mixture. If it's formed from different parts clearly seen by eyes, it's a heterogeneous mixture. Classify each of the following as element, compound, homogeneous mixture, or heterogeneous mixture. Pause the video, write down your answers, then start it again when you're ready. In the first picture, all atoms are alike, so neon is an element. Water is formed from hydrogen and oxygen, so I have two types of atoms chemically combined, and then water is a compound. It's clear that salt water is formed from two substances, water and salt, so it's a mixture. Does this mixture have a uniform appearance? Once salt is mixed with water, I'm not able to differentiate between particles of salt from the particles of water. So, water is a homogeneous mixture. What about salt, mud water, and iron? It's clear that salt is formed from two types of atoms chemically combined, which are sodium Na and chlorine Cl. So salt is a compound. Mud water is formed from two substances. What are they? Soil and water. Are these substances chemically combined? No. So I have a mixture. What about the appearance of this mixture? Is it uniform? No. It's clear that we have two parts. One part for soil, which is suspended down, and another part for water. Accordingly, mud water is a heterogeneous mixture. Concerning the iron, it's clear that I have only one type of atom. Then iron is an element. The last two examples are sugar and brass. It's clear from the chemical formula of sugar that it's formed from three types of atoms, chemically combined, which are carbon, hydrogen, and oxygen. And then sugar is a compound. Maybe you're not familiar with brass. It's a mixture of two metals, zinc and copper. Are you able to differentiate the particles of zinc from the particles of copper? No. So, brass is an example of homogeneous mixtures.